Today we'll be discussing parent function attributes. This is part 2. We'll be discussing domain, range, intercepts, asymptotes, and end behavior. This is TEKS Algebra 2A. First, we're going to discuss the rational parent function. The equation for a rational parent function is f of x equals 1 divided by x. The domain is going to be a little bit different here. We have negative infinity to 0, and we have 0 to infinity. That U sign is a union symbol, which represents the word and. For the range, we also have negative infinity to 0 and 0 to infinity. There is no x-intercept. There is no y-intercept. But the reason for the union is because there are asymptotes at x equals 0, which means this graph is never going to touch x equals 0. And there's also an asymptote at y equals 0, which means your range is never going to touch 0. Now to discuss end behavior. So we look at the left side and we have as x approaches negative infinity, your f of x is actually approaching 0. And we have the one on the right side that as x approaches positive infinity, your f of x is approaching 0. Now this one has two additional ones. We have the one below, which is as x is approaching 0 from the left side, your f of x is approaching negative infinity. And we have the one on top, which is as x is approaching 0 from the right side, f of x is approaching positive infinity. Now to focus on the domain. So in interval notation, it's set negative infinity to 0 and 0 to infinity. But inequality, it's going to be written as negative infinity is less than x is less than 0. And 0 is less than x is less than infinity. For the set builder notation, it's easier to write it that x such that x is equal to all real numbers, except x cannot be equal to 0. Now we'll look at the range. In the interval notation, we had the negative infinity to 0 and the 0 to infinity. In equality form, we have negative infinity is less than y is less than 0. And 0 is less than y is less than infinity. Set builder, the preference normally is y such that y is equal to all real numbers, except y cannot equal to 0. The next parent function we have is the exponential parent function. The equation for the exponential parent function is f of x equals 2 raised to the x. The domain is going to be negative infinity to infinity. The range is going to be 0 to infinity with a parenthesis. 0 is not included. So there is no x-intercept because it's never going to touch the x-axis. It does cross your y-axis at 0, 1. Now to discuss asymptotes, that y equals 0 is an asymptote because the graph's going to approach it but never get to it. For end behavior, on the left you have as x approaches negative infinity, your f of x is approaching positive infinity. And on the right hand you have as x approaches positive infinity, your f of x approaches positive infinity. Now to focus on the domain, in interval notation, it's negative infinity to infinity. Inequality is negative infinity is less than x is less than infinity. And set builder can be written in two ways. X such that negative infinity is less than x is less than infinity. Or you can say x such that x is equal to all real numbers. Now to look at the range in the interval notation, it is 0 to infinity. And inequality notation, it's y is greater than 0. It is not equal to 0. And set builder is going to be y such that y is greater than 0. The next parent function we're going to look at is the logarithmic parent function. F of x equals the log of x. The domain is going to be 0 to infinity, but 0 is not included. The range, it is going down forever, so negative infinity to positive infinity. It does have an x-intercept at 1, 0, but it does not have a y-intercept. It's never going to get to the y-axis because there's actually an asymptote at x equals 0. Now to look at end behavior, on the left-hand side, x is approaching 0, but your f of x is going to approach negative infinity. And on the right-hand side, as x approaches positive infinity, your f of x is also approaching positive infinity. Now to look specifically at domain, in interval notation, it was 0 to infinity. In inequality, we're going to put x is greater than 0. It is not equal to 0. So set builder is x such that x is greater than 0. Now to look at the range. In interval notation, the range is negative infinity to infinity. In inequality, it's negative infinity is less than y is less than infinity. And in set builder, we do have the two ways. We have y such that negative infinity is less than y is less than infinity. Or my preference is y such that y is equal to all real numbers.